What's up, young mathematicians? Thank you for stopping by here at Tau 2 Pi. I am Caesar the Tutor, and today we're going to be talking about monomials and polynomials. First, we're going to be talking about monomials and what a monomial is, because I think it's important to understand what a monomial is first before we dive into polynomials. Then we're going to be talking about polynomials and what makes a polynomial. And finally, we're going to finish with how to name a polynomial based on the number of terms and the degree of the polynomial. So let's get started with the lesson. Let's begin by breaking down the word polynomial. Now you may have noticed that we have a prefix here called poly, and poly is the Greek for many. So in this case, we have something that means many nomials. And before we can begin to understand many nomials, let's understand what one nomial is. And if you were to tell me that a single nomial is a monomial, I wouldn't fault you for it. But in math, we're going to call it monomial, and we're going to get rid of that extra no. Now, what is a monomial? A monomial is a mathematical term that involves the multiplication of possibly different powers of variables. The powers have to be positive integers or zero, and there has to be maybe a constant in there. So let's see how we get here. This one, we have a one variable x, a power of 3, and it's being multiplied by a 2. So this perfectly qualifies for a monomial. Furthermore, because the highest degree of the variable is 3, we call this a third degree monomial. In this case, we have just a constant and a single variable, which it's the multiplication of a constant and a variable of different powers. Well, it's just one power of 1. So this is also a monomial. Because this is in the first degree, and the highest one is 1, this is a first degree monomial. Now here we have something a little different. We have two different variables. And according to my definition, this doesn't disqualify the fact that it's a monomial. You could have two different variables in a monomial. So we have different variables of different powers, or, maybe the same power, and a constant. The constant here is 1/4, and they're being multiplied. So everything's fine. We have a monomial. Now, here we said this was a third degree, because that is a 3. Here we know that's a 1, so this is in the first degree. But whenever you have monomials of different variables, such as this one, you have to consider the sum of all the powers. So in this case, because this is the power of 1 and this is the power of 2, the degree of this monomial is 3. So this is in the third degree. And these are all perfectly valid monomials. Now let's take a look at the ones on this side. Well, this one might seem a little confusing. It says x, y squared z divided by 2. And you might be thinking, well, there's a division in there, and you said it was multiplication. Sure, but remember that this half, or this 2, is simply another way of saying 1/2 x, y squared z. So in that case, it's a perfectly acceptable monomial. It's a monomial of 3 variables. And in this case, my degree is going to be 2, 3, 4. So this right here is in the 4th degree. Now we go to this one. Now this one already has a problem in that it violates the fact that the law that says that these have to be positive integers or 0. This is a negative integer, so right away we're going to say this is not a monomial. We're not even going to consider the degree. We're not going to consider any of that. Now here we have another one of those specific or particular situations in which there is a division, and now you're going to see why this is not allowed. Here we have the exact same situation we have here. This y is actually a y to the negative 1. This is like saying 7xy to the negative 1, and there you go. That breaks down, and it is no longer considered a monomial. Now, the important thing to note here is this and this, these two right here, are monomials in one variable. This one is a monomial in 2 variables, and this is a monomial in 3 variables. The fact that it has different variables does not disqualify it from being a monomial. However, if I were to ask you on a test, identify the monomials of one variable or in one variable, and you were to, do that one, that would be wrong. So the only monomials in one variable are this one, but these are actually all acceptable monomials in their own variable quantities. Now that we have a little bit more understanding onto what a monomial actually is, we can actually begin talking about polynomials, because a polynomial is just the sum or difference of monomials. So we can actually take all these monomials and add them or subtract them in any way we want, and the result is going to be a polynomial. So here we go. We get 2x cubed plus 6x plus 1/4 xy plus 1/2 xy squared z. Now that's not a very beautiful polynomial, but it's still a polynomial. And I may not have written it in standard form, and we're going to go over what that means in a minute, but this is still a valid pre-polynomial. It has the sum of different monomials. So that's the first thing that you want to identify. You want to identify whether the terms in the expression you're given are a monomial first. If the terms are monomials, then their sum is going to be a polynomial. Of course, there will be certain requirements, and in the courses that you're going to be taking this year, you're most likely not going to be talking about polynomials of 2 or 3 degrees. Most likely you're going to be talking about polynomials in 1 degree. So all this xy and xyz is not going to be seen, and we're going to be talking about those later on. We identify a polynomial by 2 things: the number of terms and the degree. The degree of a polynomial is simply the power of the highest term in the polynomial. Okay, so if the highest power is a square or a 2, then it's a 2nd degree polynomial. If the highest power is a 10, then it's a 10th degree polynomial. Now here I have some special names for some of these. For example, a degree 0 monomial is simply a constant. The case x to the 0 equals 1. So that's simply a constant. Okay. Degree 1, well, degree 1 is going to be called linear. So anytime you have a polynomial that is a degree 1 polynomial, it's going to be linear. Degree 2 is called quadratic. And the 3rd degree is called cubic. Now, of course, there's more names for that. There's quartic and there's more, but most of the time you're just going to encounter these right here. After that, you simply call it by the degree: 4th degree polynomial, 5th degree polynomial, 6th degree polynomial, 20th degree polynomial. Now, number of terms goes by our prefixes, right? So now we're going to have monomial for 1 term, binomial if you have 2 monomials added together, binomial, trinomial if you have 3 nomials added together, and then if you have 4, we're going to call it a quadrinomial. Now, after that, we're simply going to call it a 5-term polynomial or a 6-term polynomial or a 7 or a 20th term polynomial. We're not going to get into the details of trying to come up with specific prefixes for anything bigger than that. Let's take a look at a typical problem that you might get, which would be something like identify this polynomial by degree, by number of terms, and put it in standard form. So let's see, standard form simply means that you're going to want the highest degree first. So we're going to go around and identify each nomial and put the highest degree first. Now the highest degree is going to be x to the 5th, which means that this whole term should be the leading term. So I'm going to take it and I'm going to put it here, negative 10x to the 5th. Now I'm bringing the negative along with it because this negative belongs to the 10. And we're done with that term. Now the second highest term, x to nothing, x, so it's a square term. So I'm going to take this whole thing and I'm going to say plus 2x squared. Now we're done with this term now. The next one should be one below the 2, so the 1. So let's see if we have any 1s. Well, we have 2. We have this 6x and we have this 3x. And at this point, we're just going to combine like terms, and we're going to say 3x plus 6x equals 9x, so plus 9x And then finally, we're going to throw in the constant term, which is going to be my plus 5. And if we had to identify this, well, first we have to find the highest degree. And the highest degree is a 5th degree. So this is going to be a 5th degree. 5th degree. And how many nomials does it have? Well, I see 1, 2, 3, 4. So it's a 4th term polynomial or a quadrinomial. So it's a 5th degree quadrinomial. That is all for today's lesson. Thank you for stopping by. If you like the video, make sure to hit the like button. If you want to see more content like this, make sure to hit the subscribe button. And if you have any questions, comments, concerns, or emotional outbursts, make sure to put them in the comments below. Thank you.